Hello students, here I am coming for the 7th lecture of the topic electrostat. We are discussing electric charge and how to calculate force acting on point charges. We discuss many questions based on that. My advice is you should go through the first 6 classes one by one and make habit of using pen and paper, then you will get the whole concept properly. Today I am going to discuss the concept of equilibrium in electrostat by looking at force acting on point charges. Look at the concept first. Say for example, any 2 point charges present, I am just naming them as Q1, Q2. Any 2 point charges present, their sign not mentioned. I am assuming, say they are positive, they may be positive, negative, anything. If both positive, Q1 will be getting a repulsion in this side and Q2 will be getting a repulsion in this side. So if you release them here, they will move away from each other. I hope no difficulty in that. Okay. If any one positive, say this one positive, but this Q2 is a negative, then there is attraction. There is one attraction between them. So because of that, Q1 will move in this side, Q2 will move in this side. So what is learned? If only 2 point charges present, maybe of any nature, maybe same charges or opposite charges, they just cannot remain in equilibrium because each getting force due to electrostatic force. Total force is non-zero. If total force is 0, then only you can say it is in equilibrium. Now how to identify the condition of equilibrium, exactly what to do, for that I want to explain one question now. My advice is you should write the question. So use pen and paper, you should be ready with pen and paper to write the question. Now this question I am going to first explain and then how to solve. The question is, you write, please write 2 point charges, small q and 4q. One is small q, other one is 4q. 2 point charges q and 4q are kept separated by a distance L. Are kept separated by a distance L. Find the magnitude, nature and location. Question carries 3 parts. Find magnitude, nature and location of a third point charge Q dash. Find magnitude, nature and location of a third point charge Q dash such that the system remains in equilibrium. I hope the question is written by you. Now, once that question written, I am coming for the explanation. Look at what is written. 1q here and 4q here. Their sign not mentioned, so I am assuming both positive. If both positive, this q will be getting a repulsion like this, 4q will be getting a repulsion like this. Neither of them lies in equilibrium. Equilibrium meaning total force acting on each of them should be 0. Now in the question we have to select a third point charge and we have to find the magnitude of that, nature meaning plus or minus, and location such that the system remains in equilibrium. System meaning not only q and 4q, that new charge what you assume, that also should be in equilibrium. Now let me make first a guess for the location. What should be the location? First of all, not known, I am just explaining the whole thing. We have 3 ideas. One, we can place the new charge along this line one option. We can place somewhere here or somewhere here. All these three options, let me analyze one by one. If you consider your third charge somewhere here, say Q dash, then this Q will repel this Q dash, and this 4Q also will repel it like this. So because of that, forget about what happens to Q and 4Q. This Q dash, because of these two force, will go in this direction. So this Q dash cannot remain in equilibrium. So a location here is invalid. It is not the correct location. Let me select one location here. Say for example, the Q dash place here. Same concept. This Q is creating a repulsion. This 4Q is creating another repulsion. Because of that, it will go in this direction. Then also it is not in equilibrium. So what is understood? A location here or location here cannot create equilibrium. Clear? Now we have two option sec. The third option, it should be along this line. Now along this line we have two options, one near this charge small q, other one near this charge 4q. Let me identify whether near small q possible or near 4q possible. If you consider the charge near 4q, maybe in this side of 4q or maybe in this side of 4q, anyone will observe, then as the considered charge is closer to 4q, more force acts on q dash, and the considered charge at a distance very large from that charge at the left q. So this q dash getting unequal force, one force because of 4q which is bigger and one force because of q which is smaller. Why? It is at a larger distance. Charge is also small. Here it is smaller distance, charge is bigger. So here more force, and because of this one lesser force. So two unequal force cannot create equilibrium. For equilibrium, they must be in opposite direction and they must be of same value. So a point charge q dash, if you place near 4q, then also equilibrium is not possible. Possible only when placed near small q along this line. Clear? Now near this small q possible. It is not possible here, it is not possible here, it is not possible near the bigger charge. Now, we have two options. We can place it here, we can place it here, near small q. Already discussed, near 4q not possible. If you consider near small q somewhere here, say q dash, initially what is q and what is 4q, their sign is not mentioned, meaning they are positive. But in the question written, whatever q dash available, this one, this q dash you have to identify nature also, meaning in the question not written whether it is positive or negative. Clear? Now, if not sure whether it is positive or negative, let me go for the explanation. Say this charge is positive. I am not sure, I am making a guess. I am just showing how to observe. This q will be repelling this q dash in this side. This 4q will be repelling it in this side. So force in opposite direction is there, so they may cancel. But that q dash may remain in equilibrium because they are force in opposite direction. But if you consider equilibrium of q, nowhere written in the question that third charge should be in equilibrium. Question was whole system should be in equilibrium. If you want to make equilibrium of this q dash if positive, it is creating a repulsion like this, and if this 4q also positive, it is also creating a repulsion like this. So this q is getting a total force in this side, meaning if that q dash is positive, that q dash will remain in equilibrium, but this q will not be in equilibrium. Similarly, the other 4q also not in equilibrium. So what is understood? Charge should not be positive, charge should be negative here. Clear? So a negative charge here can create equilibrium. Let me show the observation in this side also. If you consider the charge here placed not here, say somewhere here. Say I am considering a q dash charge. It is, if you consider equilibrium here, it should be a negative charge. Now I am considering, say for example, equilibrium here, not known. I am just showing the whole procedure of observation. Observation is the main thing. If you get the idea how to observe, you will get the answer immediately. Calculation requires no time. Observation needs time, or understanding needs time. This Q dash, because of this Q getting a repulsion like this, and because of this 4Q also getting a repulsion like this. So this Q dash cannot remain in equilibrium here if it is positive charge. By chance this is negative charge, then this Q will attract, this 4Q will also attract. In that case, both the force in the same side, then also it cannot remain in equilibrium. So finally, one conclusion, that equilibrium position should be in between the two charges, somewhere closer to small q. So I am drawing separately now. I think observation clear. So this is q and this one 4q. This distance between them is L written in the question. Observation shows the charge which is required should be here. So this distance is x. So obviously distance from the other side is L minus x. Clear? We should look at equilibrium of this new charge. We should also look at equilibrium of this q as well this 4q. Already explained that q dash is negative, meaning it should be of negative charge. I am going to show everything by mathematics. Just look at that. I hope no difficulty in that. Okay. I am looking at q dash. So I am writing for q dash. For q dash, force should be 0. Why? Because in the question written, we have to get the condition of equilibrium. So I am writing condition of equilibrium for q dash. Q dash getting two force. One because of q in this side, one because of 4q in this side. If by chance q dash negative, then also it is getting two force, one in this side, other one in this side. So anyway, force because of them should be equal. So it is 1 by 4 pi epsilon naught q into q dash by x square. I am writing force between q dash and q. Distance is x. From the other side I am writing 1 by 4 pi epsilon naught. These two charges I am writing, it is q dash multiplied by 4q. This is q dash, this is 4q divided by L minus x square. Total distance was L, this part is x, so remaining part is L minus x. Now 1 by 4 pi epsilon naught from both sides goes cancel. Why I am making equal? Because total force should be 0. They are already in the opposite side, so total force should be 0. Be it positive charge, be it negative charge, anyway answer is same. So q goes cancel. After cancellation, what you get? Q dash also goes cancel, q also goes cancel. It is 1 by x square equal to, it is 1 by x square equal to right side 4 by L minus x square. If you go for square root of both sides, it is 1 by x equal to 2 by L minus x. So it is L minus x equal to twice x. So after calculation, x equal to, actually thrice x equal to L. So x equal to L by 3. So at what distance the charge should be placed? It should be at a distance L by 3. Clear? Meaning this distance should be L by 3, total was L. I hope no difficulty in that. This q dash, if positive or if this q dash is negative, in any way q dash remains in equilibrium. But be careful, we are not looking at equilibrium of q dash, we are looking at equilibrium of q as well for q. So by this we get the distance only. If this q dash is positive, this q will repel, 4q will repel, they goes cancel. If by chance this is negative, there is one attraction in this side, there is one attraction in this side, these two attractions should go cancel. Anyway, answer is this. Now I am going to discuss the other part. Clear? From here, how to get the value of q dash, because till now only location identified. In the question there was three parts. We have to find magnitude, we have to find nature and location of the third charge q dash. Till now only location identified. Okay, let me go for the next step. So till now what is identified? The charge q, here 4q, this distance was L, and after calculation we get the new charge should be at a distance L by 3, meaning this distance L by 3. I hope no difficulty in that. Okay, this charge is q dash. Now I am interested in finding the value of q dash. Already observation shows this q dash should be negative. Why? By chance this q dash is negative, then this q will be attracted by q dash and repelled by 4q. So they get opposite force. Similarly, because of this minus q dash, 4q gets one attraction like this, and because of this q, it is getting a repulsion in this side. So they goes cancel. So equilibrium possible only when this charge is negative. Okay. Now I am writing, I am actually interested in finding value of q dash. For equilibrium, I am writing in short, for equilibrium of q. So I am writing force acting on q because of minus q dash should be equal to force acting on q because of 4q. So this q getting two force, one because of minus q dash, one because of plus 4q. Now let me write the value. Already we know at the time of calculating force, we never write plus or minus sign of the charge. Instead of that, we will write the value, direction we will show in the drawing. So here in the direction, direction shown. It is 1 by 4 pi epsilon naught. Force between these two I am calculating. So it is q dash, actually minus q dash, no need to write. Distance is L by 3 square. The other one, 1 by 4 pi epsilon naught. Distance between these two is q 4q. Distance between them is L square. 1 by 4 pi goes cancel. 1q also goes cancel. So it becomes 1 by 4 pi epsilon naught, no need to write. Q here and q here also goes cancel. So what left? This on squaring 9q dash by L square. L square also goes cancel. It is 4q by L square. So q dash from calculation 4 by 9q. So we get the value of the charge also. So you have to write the required charges. I am writing in short. You have to write the whole word required. The required charge is q dash equal to minus of 4 by 9q. Clear? It is to be placed. It is to be placed at L by 3 away from the charge small q. So quite interesting question. The equilibrium requires good observation. So this is the first question on equilibrium. I am showing another question on equilibrium now, just to give the idea properly. In this case, both the charges were positive. You may get the question with charges negative. So let me show the example. Say another question I am considering. Say here one charge present. Say for example, say 16q, and another one present here. Say for example, minus of 9q. In my previous case, both the charges were positive. Now I am considering one positive charge, other one negative charge. Question same. Clear? You write the question first. With the drawing, you have to write the question. Drawing is this. Write the question. 2 point charges 16q and minus 9q are kept separated by a distance L. 16q and minus 9q are kept separated by a distance L. Find magnitude, nature and location of a third charge q dash. Find magnitude, nature and location of a third charge q dash such that the system remains in equilibrium. Such that the system remains in equilibrium. I hope question written. Okay, let me show the discussion. That charge q dash we have to place where not mentioned, the location to be measured, identified. So this observation, like similar to the last one, somewhere above the line or somewhere below the line, not possible. It should be along the line. Again, near the bigger one, not possible. It should be near the smaller one. So near the smaller one, two options, either here or here. I hope no difficulty in that. In last class, so the observation idea shown, along the line is possible, not above the line or not below the line. Again, near the bigger surge not possible, it should be near the smaller surge. So whether left side or right side, let me observe. Say for example, I am placing my surge q dash here. I am just showing the observation. Say unknown surge is placed here. If that unknown surge placed here, it may be positive, it may be negative. I am considering say positive. Then this q dash is attracted by minus 9q and repelled by 16q. So it is getting force in same side. Meaning it is not in equilibrium. Okay. If by chance this q dash is negative, then this minus 9q will repel it and this system q will attract it. In that way also both the forces in the same direction. So it is not possible here. In the previous case, it was possible there. Are you getting the trick? I hope some idea comes out. So now the possible point is somewhere here, q dash I am considering at some x distance. So it is possible here. Why? If you consider q dash here, whether it is positive or negative, we will observe. If it is possible here, just I am showing say it is positive charge, I am making a guess, it may be negative also. If it is positive charge, minus 9q will attract and this 16q will repel. So they are in the opposite side. Minus 9q will attract and 16q will repel. So there is a chance. It is not that this should be in equilibrium, that minus 9q as well 16q also should be in equilibrium. If the considered charge is positive, minus 9q gets one attraction in this side and this 16q will give one attraction to minus 9q. So minus 9q also getting force in opposite side. So here the force will be cancelling each other. In case of q dash surge, it is also cancelling each other in case of minus 9q surge. So required surge in this case will be positive and it should be placed at the right side of the surge minus 9q. Okay, how to do? Just two step, mathematically only two step. That is why the whole idea explained in the first one. So first step is for equilibrium of q dash. First of all, we should look at equilibrium of q dash. How? Force acting on q dash because of minus 9q should be equal to force acting on q dash because of 16q. This q dash getting two force, one because of minus 9q will attract and this 16q will repel. This attraction and repulsion should go cancel. So force acting on q dash because of minus 9q should be equal to force acting on q dash because of 16q. Clear? If you put their values, it is 1 by 4 pi epsilon naught q dash into 9q by, what is the distance between them? Q dash here and 9q here, this distance is x. So x square. Already we know plus minus no need to write, instead of that direction to be observed. Force acting on q dash because of 16q, it is 1 by 4 pi epsilon naught. It is q dash into 16q by, what is the distance now from 16q? L plus x square. My advice is simplification will give you what is x. I am sure you are quite capable of doing the simplification. So this gives you x, and if you put the value of x is known by this. If you put the value of x at the time of calculating force on 16q or minus 9q, you get the answer. Just let me show the step. So I am now writing for equilibrium of 16q. So force acting on 16q because of q dash should be equal to force acting on 16q because of minus 9q. Let me show the drawing of the question. I am looking at this 16q. Minus 9q will attract it. It is force because of minus 9q. And this q dash will repel it because q dash positive already identified. So it is force because of q dash. So 16q getting 2 force, they are in the opposite side. Just make them equal. So if you write the value, it will be 1 by 4 pi epsilon naught 16q into q dash by the distance available L plus x square. Out of that, x is already measured from the first equation. If you write between them, then also 1 by 4 pi epsilon naught 16q, it is multiplied by 9q, no need to write minus sign. 16q and 9q, their distance was L, already x measured, so by solving q dash comes out. So in this case, required charge q dash, it is positive as observed, distance will be at a distance whatever x coming from the solution. Clear? So my advice is try question of this kind. It is available in any good book of physics. So you should do properly. Clear? Calculation you should do from your side. My advice is go to the observation. If you learn how to observe, remaining part is very easy. We are looking for competitive exam, so concept should be perfect at the time of using it. Clear? Hope it is understood. Thank you.